Marginal analysis in business and economics. Marginal means derivative. If you are given any function, you simply take its derivative, you will get that marginal of that function. If you are given cost function, take its derivative, it will be marginal cost. If you are given revenue function, take its derivative, you will get marginal revenue, and likewise for the profit. For example, here you are given a cost function. If you take its derivative, we are denoting derivative with this dash, you will get marginal cost function. And similarly, if you are given a revenue function, you take its derivative, you will get marginal revenue. And likewise for the profit function, if you are given profit function, you take its derivative, you will get the profit function. Now what is marginal revenue and what does it mean? Marginal means the cost of producing extra item. Let's say the cost of producing x plus 1 item is something else, and the cost of producing x item is something else. Then what is the cost of producing that extra item? So you can subtract their total costs and you will get the cost of producing that x plus first item. We can take an example. If the total cost of producing x electric guitar is this, then what is the cost of producing x plus 1 guitar? Or the find the exact cost of producing 51st guitar. The cost of producing 51st guitar, this extra guitar. So simply we will substitute c of 51 into this function and c of 50 into this function, and we will subtract c of 50 from c of 51, and we will get the cost of producing 51st guitar. And if we take the derivative of this function, you can directly get the marginal cost or the cost of producing 51st item, which is 100 minus 0.5x. You can substitute here 50 and you can get 75. So here you can see exact cost of producing 51st guitar is cost of 51 guitars minus cost of 50 guitars, give us the cost of that extra guitar, which is 51st. Or you can take the derivative of this cost function and you can get the cost of 51st guitar. Now after calculating marginal cost, there is another definition which is called marginal average cost. Whatever cost function is given, you first divide it with the variable which is involved in that function, x. So divide the whole function with x, you will get average cost function. And further, if you take the derivative of that average cost function, it will give you the marginal. Now this is marginal average cost function. So here you can see that c of x is given, you divide the variable which is involved, x whole function, and then you can get average cost function. Then after this you take its derivative, you will get average marginal average cost function. Likewise for revenue function, if you are given any revenue function, divide it with the variable which is involved in that revenue function. What does it mean by saying, if you are given r of t, divide whole function with t. If you are given r of y, divide whole function with y. If you are given r of let's say z, divide whole function with z. So you are given function in terms of x, so divide whole function with x, it will give you average revenue function. Then you take its derivative, it will take you into marginal average revenue, and likewise for the profit function as well. The total cost of printing x dictionary is c of x. Find the average cost. To get the average cost, we simply divide c of x with x, so it will become 20,000 this over 10. Find the average cost per unit. If 1000 dictionaries are produced, you can simply substitute 1000 and you can get the result, which is 30. So here you can see we simply divide c of x with x and then we substitute 1000 and we can get the average cost of producing 1000 dictionaries is 30. Find the marginal average cost at the production level of 1000. So first of all, marginal average cost. First of all, we will get the average cost function, which was average marginal average cost derivative of average function. So first of all, we convert cost function into average function, which is divide whole function with x, which is 20,000 over x. Now we take its derivative, we move x to the numerator. Now it will become minus 20,000 x raised to power minus 2, and derivative of 10 is 0. We can write it in this form. So this is how we take its derivative, minus 20,000 over x square. And in order to get the cost of average cost of producing 1000 dictionaries, you can simply substitute 1000 and you can get the result. You can see here we simply substitute the 1000, the average cost of producing that extra 1001 dictionary. It means that its cost will reduce by 2 cents. Use the results from above to estimate the average cost of 1001 dictionary. As I said, we simply substitute 1000 into the function, and we can get the marginal average cost, which is minus 0.2 cent. So the average cost per dictionary for 1001st dictionary would reduce by minus 2 cents. The actual cost was 30. So the cost of producing 1001st dictionary will reduce by minus 0.02, which will become 9.98. Similarly, the price demand equation and the cost function for the producing television sets are given as this. This is the price function. This is the cost function. Find the marginal cost. In case of marginal cost, as I said, simply take its derivative. If you take its derivative, you will get 30. If you take its derivative of 15,000 is 0, derivative of 30x is 30. Next it says find the revenue function in terms of x. Now this is an important thing. The revenue function is x times p. Now we get the function of p in terms of x from price function. From price function we will substitute p of x from the price function and we will get revenue function in terms of x. Now find the marginal revenue. To get the marginal revenue, we simply take its derivative. It will be 300 minus 2x over 30. So revenue function will be marginal revenue function will become this. Find revenue marginal revenue at 1500. So simply substitute here 1500 and interpret the results. How we will interpret that? The cost of producing 1500 and first item, the production rate of 1500, each additional set increase revenue by approximately 200. If you produce 1500 and first item, your revenue will increase by 200. So graph the cost function and revenue function on the same coordinate and find the break-even point. Break-even point where your cost function is equals to revenue function, or where your profit function is 0. So you're quite expert in finding the graph, so you can plot the cost and revenue function. This portion is your profit function. This function is your profit. Before this is your loss, and after this is your loss. Find the profit function in terms of x. So here we have profit function in terms of x. Find the marginal profit. How did we find this profit function? As you know, is revenue function minus cost function. You have revenue function in this example, you have cost function. You can simply take their subtraction and you will get profit function, which is given above. And in case of finding the marginal profit, you simply take its derivative and you can get the marginal profit. So marginal profit will be this. and you can substitute 1500 and you can get what would be the profit, additional profit of producing 1500 and first item. So your profit will increase by 170 if you produce more than 1500 items.